substitute for river sand, facts and factual, myself Chetanji Konapure, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Now, this is the learning outcome. Student will be able to describe the facts and factual of use of crushed sand as substitute for river sand. Now, these are the facts, and in facts, problem faced in past due to the use of dust. So, crushed sand was known as dust in earlier days because the powder content was more in the crushed sand. That's why it was known as dust, and that was used in the concrete. What are the issues? Low strength concrete. Second, de-shuttering problems, means because of during de-shuttering, corners of the beams and columns are damaged, and that was the issue. Third is cracks formed on slab surfaces. Now, that is the issue on the second day after casting of the slab. Fourth, improper bonding among particles. Fifth is honeycombing. Honeycombing is increasing because of this use of crushed sand, which higher content of dust. Sixth is concrete surfaces having whitish colors. That is because of the higher content of dust. Seventh is disintegration of concrete, and eighth, if you study all these 7 points, if you observe these 7 points, definitely there will be the durability issues, and the basic cause for that is higher void content. Okay, now let us see the photograph. Whatever I was discussing, that the facts which the problems faced, if you observe the corners of these columns, which are at the plinth level, the corners are damaged, the edges are damaged. If you observe this corner of the column, it is damaged. And if it is damaging at this level, so what will happen into the entire life of the structure? So, this is one of the non-destructive testing of RCC members I have carried out at some site, and this is from my consultancy report, which is carried out in my laboratory. Okay, so this is large span beam, plinth beam, the corner is damaged, and if you observe in this column, if you observe, so the edges are not proper, and all the edges were damaged during the de-shuttering. So, that is one of the issue. Now, this is non-destructive testing of one of the columns in the apartment buildings. If you observe this one, the dust particles are accumulated here, and whenever de-shuttering is done, this much patch is removed as the shuttering was removed, and that was tested whether what was the issue there with the non-destructive testing. You can see in this enlarged photograph also. Okay, now these were the issues, these were the problems because of the higher content of dust used in the crushed sand. So what is the factual? What is the reason for above problem? Now, first is improper proportioning. In M20 grade of the concrete, generally the proportion is 1:1.5:3, and how this entire calculation is disrupted, that we can see here. Okay, let us see for cement, one bag it is 50 kg. Okay, what is the practice? 10 gamelas of sand is taken, fine aggregate is taken, 12 gamelas are coarse aggregates are taken. So, gamela means one container, so which is used on the site in which the material is taken and poured in the mixer in the batches. Weight is not measured, volume is also not measured, which is irrespective of weight and volume, the 10 and 12 gamelas are taken. Now, if you see gamela sizes are 32, 36, 39, 3 sizes are coming in, which are available in the market. Any one is taken and it is used for the construction. So, there may be variation in the material for every batch. Now, let us take the example. Let us see that 50% river sand is taken, 50% crushed sand is taken. Okay. Now, let us quantify it. The approximate weight of river sand and with respect to the gamela, if you taken that one gamela is taken and measured, it is weighing it to 13 kg. 50% of the quantity is 5 gamela, 65 kg is the quantity by weight. Approximate weight of crushed sand. So, if you measure that crushed sand, so gamela, it is 19 kg because the density of the crushed sand is more. 5 gamelas are taken, 19 into 5, it is 95. So, total is 160 kg. Total fine aggregate 160 kg. But if you now weight wise, if you compare, actual river sand which has gone into the mix is 40%, actual crushed sand which has gone into the mix is 60%. We are assuming that 50% crushed sand and 50% river sand is used, but that is not correct. River sand is now 40, crushed sand is 60, and if the powder content is more, higher powder content has gone into the concrete. Now, second is inappropriate selection of the crushed sand. Now, proper selection of the crushed sand is not done. That is why over sand concrete mix are done. Okay. Now, third is dust was used to substitute the river sand. That was the issue. Improper selection of the material. No testing was done and specifications are ignored. So, if you are selecting some substitute material, you should go through the testing of that substitution material. You should go for the specification checking also. Now, these are the further issues, flaky particles, higher amount of water, then during casting, dust and fines are washed and flows out of the forms. And the partial sand is coarser in some cases, in which zone 1, if the sand belongs to zone 1, in some cases, if dust content is more in the crushed sand, then 50% of the crushed sand is dust, in which it goes to the zone 4, which is not used for the RCC. Now, what are the present issues of improper sand sample is selected? First is non-homogeneous concrete mix. Second, no workability, non-workable mix. Third is more demand of cement paste. Fourth is mixing, placing of concrete requires more efforts. Labor requires more effort, which is again the issue. Fifth is cement content increasing because of higher paste required. Sixth is improper casting leads to the corner damage of the beams and columns. Seventh is honeycombing. These are the present issues. And in last 4-5 years, the crushed sand is used. But if you go for improper sand selection, these 7 issues are always observed on site. Now, what precautions shall be taken if we are using substitute material of the crushed sand for river sand? Okay. First is correct weight or volume of crushed sand shall be taken. Go for the Pharma, 1 foot length, 1 foot breadth and 1.25 feet depth. That proper size shall be taken. It weighs 60 kg of sand. Okay, now the size of gamela, if you are using, okay, to keep that same throughout or constant throughout the construction, and at least weight of 1 gamela shall be measured and continued the same. Second is controlled water, 5 liter can shall be used, which exactly measurement of the water shall be done during the mixing. And the water cement ratio shall be maintained 0.5 for M20 grade of the concrete, maximum up to 0.53. Now, mixed proportion for M20, several times after calculation for these nearby materials it is observed, 1:2.1, 1:3.3. So, cement is 50 kg, sand is 100 to 115 kg, coarse aggregate is 160 to 70 kg, and in the form of gamela, it is 1 bag cement, 8 party 8 gamela fine aggregate, 11 party coarse aggregate, 11 party. So, 1:8:11, 1 bag cement, and these are the other volumes for fine aggregate and the coarse aggregates. This precaution shall be taken. Now, third is chemical admixture is needed. Plasticizer shall be used for a normal grade of concrete, M20 grade of concrete. Water reducing agent shall be used. Workability aid shall be used because the workability is hampered because of the crushed sand, because it uses frictional resistance more. For structure with combination of the steel reinforcement, super plasticizer shall be used. 1.6 to 1.5% weight of cement, the dosage shall be given, and it shall be given into the weight mix, not in the dry mix. And proper compaction, needle vibrator is required, it is needed. Without a needle vibrator, without vibrator, the mix with crushed sand shall not be made. Now, what are the advantages? If you go for the proper selection of the crushed sand, proper construction practices, then definitely this advantage you will get. You will get more strength or higher strength than the river sand, at least 20% more. You will get more dense concrete. Durability of concrete will be increased. Lower cost, as compared to today's river sand rate, the crushed sand concrete will be lower cost, having lower cost. Exact volume, no bulkage, that is one of the issues. Low water absorption. If you use proper dust, if you use proper dustless crushed sand, there will be low water absorption, and high early strength, which is not possible in the river sand. In crushed sand, definitely we will get high early strength in 3 and 7 days because of shrinkage is the basic issue in earlier days, and the micro cracks are there always in the river sand, but these micro cracks is very reduced with a substantial amount in the crushed sand concrete. How this sample shall be identified? Now, gradation of the sand shall be checked in IS 8383, zone 1 to 4, where the crushed sand belong. Coal and lignite shall be 1%, clay lump shall be 1%, total it shall be 2%, and permissible limit of material finer than 75% is 15%, that is the powder. That powder content must be arrested or restricted to the 15%. Field check-in. The crust sand shall be granular, spherical, smooth particles. Deleterious material shall be very less, dust shall be very less, clay lump shall be very less, fine particles shall be restricted to the 15%. Now, what is the economy of this sand? If you are going for 1000 square feet construction of a ground floor residential building, cement for RCC work generally it is required 300 bags. Cement for other works, brick work, then plaster and other work, 150 bags. Sand quantity for RCC work is 15 brass required. 15 brass means 15 into 3.228 cubic meter. I am talking into the site language. Sand quantity for other works 15 brass, total is 30 brass. So, 30 brass minimum is required for 1000 square foot of residential building. Now, if you apply the rate of river sand 30 into the rate of river sand, that will be the total cost of fine aggregate required, and generally the river sand is 1.5 or 2 times more than the crust sand, which will be increasing your cost of entire project. Now, this is the one of slab casting residential building. It's my own home, which is used, in which crust sand is used, and slump and all other tests were taken. So, if you see, you are getting the proper true slump here, and this is the casting which is done for the slab, and then you can see near column I have taken this photograph. These are the references for this session. Thank you.